of what you do at the beginning of an epidemic compared to what you do in the middle compared to what you end is, of course, interesting and different. But the uncertainty framework that you should have should be quite similar, right? I mean, the models you may choose to employ may be different, but how you still embed them and relate them to reality should be similar. The rules of sort of uncertainty, statistics, Bayesian statistics don't really change from the beginning of an epidemic to the end. What changes is the particular model you may be using, and the availability of data changes. So I would see a situation where you have a consistent framework throughout. However, in the beginning, you're of course more reliant upon prior information from expert judgment to give you rough parameter settings that you can roughly run your model forwards that gives you meaningful predictions. I mean, this was done in March here in the UK, just in a slightly more fast, slightly haphazard is the wrong word, sorry, a quick and efficient way, let's say. But you can imagine that's what you do at the beginning. Expert elicitation comes in, but then as you progress through, you get more and more information, and then you rely less on the expert information, and the data comes in and feeds you more and more, and then you're developing your model in the same way. So the temporal aspect is very interesting. The uncertainty framework should be the same. What is also interesting is then you bring in different models, as Danny says. So then obviously, then you have to, you're confronted with the issue of, well, why did I bring in a different model? Well, because my previous model was insufficient. It didn't give me the detail I wanted, or because I think my previous model was inaccurate. It wasn't quite right. And then the history of model development is always about that, right? Your model today, you like it, but your model from 2 weeks ago, you don't like it. And why is that? Because 2 weeks ago, it's not quite right. It's not quite good enough. So yes, so the framework should really, if you have a consistent framework that survives, and by that I mean an uncertainty framework with your model sitting in and your data sitting in and your experts sitting in and reality sitting in, which is what I always bang on about. I'm sorry, my apologies. That should incorporate all this sort of stuff, and explicitly it should incorporate that your model has an added uncertainty because it has missing stuff in it. And that's not an uncertainty coming through from the uncertainty on your data or the uncertainty on your experts who are listing stuff or anything like that. It's because your model isn't the same as reality, has missing stuff. Now, once you have that in, everything now makes sense, because you can compare two models because they have different things missing and they're different from reality, and you can embed them in one structure and learn from them, a bit like what Danny was talking about when you combine models. So yeah, so I'm very interested in everyone's discussion. The temporal aspect is interesting. I would just say the overarching framework should be the same. The pieces that come in, experts, models, they change in time themselves.
So yeah, I had a comment. So I was thinking that obviously one way to reframe this or frame the discussion in terms of the challenges is where we'd like to be next time more. So to, you know, like for example, in terms of fitting stochastic models, you know, one of our challenges might be that we just need better tools, more efficient inference for those types of models. I also probably, I'm sure Danny knows more about what's available than me, but I still think that there's scope for better validation and assessment tools for models, so that in addition to identifying that there's stuff in the models, as Ian says, that we don't know about, actually trying to help us figure out what that stuff is. I think there's some scope for that in epidemic models. And I also think that although the current data that we've had has been, you know, less than ideal, we might want to think about how we would handle the sorts of data that we might have in the future, possibly in our sort of wildest dreams. You know, so, you know, can we actually cope with a flood of data that comes from, you know, say mass testing from you know, day 2, and, you know, phylogenetic type data, which I certainly can't cope with at the moment. So I think there are challenges there in terms of estimation, as well as, you know, as Jasmina says, you know, modeling structures, and also probably, you know, some of this comes into the data side of things as well. But I think from an estimation point of view, there are some potential challenges as to how we build all that in, or we would build that in, you know, the next 10 years or whatever.
The interplay, if I can just add, if no one else is waiting, the interplay, just what you mentioned there, are between model development and identifying the part of the model that's sort of not behaving correctly, that needs fixing, and hence where should you put your effort in developing your model. The interplay between that and various statistical techniques to alert you to this is really quite interesting and is quite sort of current edge. So I've heard people say that when people came up with designer experiments, right? I mean, statisticians were not listened to about designing experiments, doing Latin hypercubes and stuff. But now in any industrial setting, that's just as standard. Well, we're kind of like there with models right now. I mean, people don't really look at the 20 improvements they could do to their model and scan through them in a very ordered, statistically designed way to identify the 3 that they really need to fix today, and identify the next 5 for next week. That's not really a thing that's done because it's hard and it's weird. It involves several different expertise from multiple different areas. So I don't know, that might be something. I don't want to just throw in more stuff, by the way, but that would be definitely a ripe area for improvement, I think.
If I can jump in, my hand is up, I promise, and I've got to drop off in a minute. So I'll just share a bit more of the experience that we've had through modelling this pandemic. So prior to the pandemic, I'd have absolutely agreed with Phil David that forecasting is absolutely the only way to sort of assess model performance and predictability. But throughout, I find now that we do this. Some of this does go on within the SPI-M teams, but I find myself being assessed as a modelling team rather than as a model. So as Ian suggested, our model is now unrecognisable to what it was a couple of months ago, and the model development is continual, and we do forecast for different reasons as well. Assuming different things about the future, which are often dependent on changes in behaviour and changes in policy as well. So I think you have to be very, very careful when specifying forecasting to be a basis for assessing model performance in terms of forecasting deaths. You've probably got about 3 weeks to do forecasting in terms of 3 weeks ahead, because the deaths the next 3 weeks are infections that have happened already, pretty much. So that's not quite so susceptible to sudden changes. If you're forecasting cases, then that's probably going to be only a few days, or maybe a bit longer, but not much. And the other thing is, as we've gone through, we've identified areas of the model that aren't perhaps performing as well, or aspects of our fitting to the data that aren't doing as well as other bits, and we've tweaked the model and corrected the fit as we've gone along. And this has the corresponding effect of rapidly expanding sample space, parameter space, sorry. And whereas in April, I was fitting my model in 2 hours and getting the results, and then tweaking the model and running in 2 hours, and then I could run the model as many times as I like and still be able to report results to SPI-M every Tuesday morning. I now have got basically two or three shots at it to get it right. I run it all Saturday, run it all Sunday, and then run it all Monday if I can, and then hopefully one of those will yield results that we like, or in a principled way, of course. And the model run times are growing quadratically, and I'm becoming as much computer engineer as statistician to try and get things to work in time. So scalable methods, scalable approaches to estimation, are particularly important, whether or not that's being able to sort of move the window over time over which we carry out estimation, or whether that's just MCMC and SMC methods we use. That I think that's a really important thing to consider.
Just a quick question. Do you guys use emulation, or is your model so fast that you don't need emulation in your situation? I know your MCMC takes a long time. Is that when you do it run on Saturday? Is that an MCMC full calculation you're doing?
That's a full inefficient MCMC, which we're trying to improve.
Cool.
We have
it's much faster if you run an agent-based model. Sorry, I just have to chip in to say that.
It's just a deterministic population model, but our parameter space, the set of things we estimate has become so large that the model itself is really cheap to evaluate. It's the fact that we have to evaluate the model that many times now is the problem.
Well, definitely tools to help you with that game, because I think that's a very common game. I mean, exploring high dimensional parameter spaces is just a very big, important game in itself, which is, I mean, there's a lot of UQ tools for that, although some of them may be applicable, some of them may not. So I think that's definitely a challenge for the whole community, I think.
There are some automated hyperparameterization search spaces like Optune, or I use Optuna, which is sort of quite quick. I can send you links to that. And even for a large scale agent-based model, I'm simulating and calibrating, I guess, a large number of parameters, and it's quite quick. Yes, it does take the weekend, but it's kind of it takes less time than when I did it before. I can send, but it's a challenge we should be addressing, I agree.
We've got quite a lot of hands raised, so we better take them in the order on the chat or something.
I have just a quick point.
I think Jumpy was first. Sorry, Mitra.
No, I'm not first, but I have the advantage or disadvantage of having missed some of your previous sessions. I just wanted to ask you, have you decided on what you would like to know? Since this is about estimation, I guess that one should start with the question, what would you like to know? And then maybe to see if there's a parameter for that can be estimated. So what would you like to know? You seem to be talking about forecasting all the time. And Paul, I guess, said the essential thing that you cannot forecast much longer than 3 weeks for deaths, a couple of days for cases, hospitalizations, 10 days. And that's it, because things are changing all the time. So nobody would forecast further, as long as you don't have sociological models, both for politicians and for populations. And I guess both of these are lacking. But so what would you like to know exactly? What is there to estimate?
Jumpy, at the moment we estimate the R number, how it changes over time. We estimate incidents. We estimate all sorts of other variables, like the probability of dying given infection, which changes over time. We are estimating some elements in the. I mean, Paul can tell you all of this, but that's what they want. They want measure of, nowcasting, so estimation of what's happening now, as well as sort of, it started with short-term predictions, which was only a couple of weeks, that's what we agreed to at the beginning. But as time went by, they wanted longer and longer and longer. So now we're producing 6 weeks and 8 weeks and 3 months, which obviously no one believes, because they are, if anything, that they could be thought at most as counterfactual, because given what we estimate now, what we predict in the future depends on the assumption that we make, and typically these assumptions are very difficult to verify, because things happen in between. So things change. Okay. So
Yes, but
the status of the epidemic now and the short-term projections, that's what we produce regularly.
But even trying, maybe this capacity of calculating things, even counterfactual, saying if things progressed as they are today, etc., what would happen in 3 months? Maybe even the politicians, the decision makers, are fooled by this, because even if they don't do anything, the population will. And so they shouldn't rely on anything, not even a counterfactual in that sense, because we have seen that population tendencies are important. Italy started a new wave of infections just because the summer came and everybody got the feeling that you could do whatever you wanted suddenly.
Well, in England, it was exactly the same.
Yes, and nobody had decided that really, that you could do anything you wanted, but people felt that way. And that's why I say we don't have sociological prediction models for people's behavior, how they react to new measures or anything.
Yeah. So this is another element of discussion. So how you embed and how you consider sort of behavior elements. But anyway, Samitra, I think, wanted to say something.
Yes.
I'll shut up because I say too much.
Just two quick points first to Ian. I mean, like there is a problem with emulating log likelihood surfaces because there's loads of non-stationarity as well as discontinuities, and so to fit an emulator, it's itself a very challenging problem. So like you have to kind of actually use things like active learning and some experiment design in actually updating your emulator while you progress through your inference. So that's a whole lot of engineering that needs to be done to get emulators working. And what I find is that there's very little incentive in actual engineering Bayesian computation. So there's a lot of incentive to come up with new models. There's also a lot of incentive to come up with new methods, but to take methods, current concurrent methods, and to actually do engineer them to get better outputs, there's lack of incentive. And so and I think also because doing those sort of engineering needs people who are fluent with both computer science as well as statistics. And unfortunately, that's not always the case. So that's my first point. And there was a second point, just a quick comment on Paul's forecasting thing, is that what I find is like when I compare like what's going on in epidemiology and I compare to other fields where prediction is like the most important thing, there is actually what a lag. There's a lag of, let's say, 5 years, sometimes 8 years of actually using updated tools. So when we say that forecasting is problematic, then we need to say forecasting is problematic using tools from 2020, not 2010. So that's also an important thing we need to keep in mind.
Could I just respond to your first point? Because that's very interesting. I'll be very quick. And you raise a very interesting point. We would not recommend emulating log likelihoods, would be my point. It's a trap a lot of people fall into because they think emulators vastly mimic surfaces, and the surface you care about is the likelihoods. So why don't we emulate the log likelihood? No, if you, I would be very happy to pass you some papers. We do not recommend that because it's a horrific surface to try and mimic. We emulate directly physical outputs of the model, which are very nice surfaces. Then we combine emulators together to produce a likelihood or something similar. So there are lots of little tricks which can help. But I agree with you in principle. It's not easy, and more development is needed.
So actually, I mean, like I mentioned log likelihood because that's like a general thing. But actually, I've tried a lot about actually taking highly nonlinear ODE models and try to kind of emulate physical outputs, and there is a problem of discontinuity. And the most prevalent approaches for using emulation kind of rely on smooth processes like Gaussian processes, which have smoothness assumptions. And actually, I think to fit discontinuous response surfaces is largely still an open problem. There are methods, but I don't think they're robust enough. And if you want to fit output of highly nonlinear models, then you need to figure out emulating techniques that can handle discontinuity. And I'm not confident that we are there yet.
Mm-hmm. Yes, I would agree. It's an active area. There are quite a few techniques for discontinuities, but I'd agree a lot more work should be done. Definitely.
I had my hand raised. Is it my? I don't like to take someone else's turn. Is it my turn to speak, Valerie, Dennis?
Yeah, I should think so. Unless Samitra just wanted to come back on that previous point.
No. I mean, like,
okay. It's just your hand still up, so I wasn't sure whether. Yeah. Yes.
Sorry,
So I have had many conversations on estimation. First, it started with UQ, then it went into expert explicitation method. Now we're talking about this, and I just wondered whether, and Janpi made a really good point. What is the point of this paper? Are we trying to describe what can be estimated and how this can be done? Or are we trying to say what is the key to estimate and how we do it in a developing pandemic? And I think these are different things. The challenges, I think, lie in all of them, but it's how you link them with each other. And as much as I'd like to go on talking about the technicalities of different models and how you do it, etc., I think maybe we could just bullet point now, and I don't mind who types, just what are the key parts of this estimation, because we did this in the modeling part and we are almost there with writing that paper. So I'm just trying to kind of frame maybe the conversation. I know that's kind of not my role, but it makes life easier, I think.
Yeah, you're right, Jasmina. Sorry. We will do that. I was meaning to start putting bullet points before today, but I better do it as soon as possible, because the more the time goes by, the less chance I've got. So I'll start with TJ. We had a little discussion, so maybe we can start, me, TJ, and Josh, and then people can add, swap, or whatever, edit.
But maybe tell us then, what do you think are the key points, like now, or somebody tell, and then if we agree with that, they can be kind of set in stone, maybe not the right word, but it's set in something for now.
I think TJ wants to say something.
Oh, well, I was just going to come in on Jasmina's point there, because so I mean, is this paper purely about the estimation problem, or is the paper about uncertainty quantification, of which estimation is part of that paradigm? Because we were discussing as well whether or not the expert elicitation might get subsumed into this as well. So that might be a good place to start, to try and, are we just talking about the estimation and the calibration problem, or are we talking about uncertainty quantification, of which estimation is a part of that? Because you would structure your paper very differently if you were, because it sounds, most of this conversation seems to be more about this general idea of UQ, different facets of it at different points in the epidemic. But if we are focusing on estimation, that might be slightly different structure. I don't know what people think about that, or what.
I think you know what I think, TJ.
Well, I know what you think.
Can I just tell you that about, I don't know what time, 1 o'clock, 2 o'clock, Glenn, myself and Ben had a chat, and we were planning the modeling paper, and towards the end of that, or a section of the modeling paper, and towards that we wrote the following sentence: faster methods for estimation, model checking, and comparison are needed, as more complex data are going to be used on more complex models. Link to estimation paper. So I don't know if that sets the beginning of this conversation, and how maybe Valerie and Dennis, correct me if I'm wrong, can this follow on?
I mean, we've had discussions on all these areas. I think the hope is that maybe they all fit into one paper, but until we really get the sort of the bullet points and some sort of logical structure down, it's a bit hard to tell. I mean, it might be that it really doesn't work and it has to break apart, but it would be nice really to put it all together, I think, if that works. But
well, I was thinking, that's why I suggested we need to understand, we need to decide what kind of slant we want to give it, whether we want to kind of concentrate on, the estimation business, is different contexts, whether we would just want to concentrate on estimation in the midst of an epidemic, which then brings within the problem that you might entertain different types of model. And definitely even the same kind of model you start with, as data accrues, as Ian was talking about, it becomes much more sort of founded on the information which is available, but it will develop. And Paul gave some ideas about what we've been doing. We started with something, but then it became different, more and more different as different challenges and different data were accumulating. So I don't know. Do we want to consider the estimation problem in the midst of an epidemic, or do we want to just focus on generic estimation problems and then all the I don't know. I think we need to make a decision. Of course, the more we think about it, the more things become clear. But for us, at least, the problem is to finding thinking time. For me, this hour that we spend together is an incredible luxury. at the moment. So let's start putting some bullet points down, and then we scrap them or whatever. But if we could start at least deciding what kind of point of view we are looking at, we are going to entertain, I think that would be useful.
Well, sorry, Dennis, you were going to say something.
Could I say the reason I, in answer to your point about different kinds of estimation, Danny, I mean, that was the reason I think I suggested that we should structure it in terms of the stages of the epidemic.
Yeah.
Because I think then it gives a sort of fairer basis for letting each kind of estimation speak when it's its turn to speak, as it were. So at the very beginning of the epidemic, when you're wondering whether there is an epidemic, whether a new disease can spread at all, this kind of thing, then, or even before that, when you are just know that there are viruses in the population, you're trying to say, what is the probability of a pandemic, and is it more likely to be one kind of disease than another? You know, these kind of things are very much questions for the most general uncertainty quantification and maybe expert judgment. Then when you get down to the kind of the middle of the storm where you are, where you're in the middle of it, where by this time we know a lot about the parameters of the epidemic, then more traditional ways of dealing with, you know, estimation for large data sets and so on become very, very relevant. So
yeah, okay,
I suggest in trying to write bullet points down, we have sort of at least distinguished middle, so very beginning, the exponential phase, the sort of middle of a pandemic like we're in now, and then maybe estimation questions to do with elimination, which is interesting again, because as I understand it, it's with the various diseases that, you know, for instance, the neglected tropical disease people are trying to get rid of, that it's actually can be very difficult to know how much prevalence there is when you get near to eliminating disease, because precisely the disease is hiding in the kinds of places where you have very bad data or no data at all. So, but I think, yeah, doing it roughly in stages like that is a good way of allowing different estimation approaches to each take a turn.
Okay. So thinking in terms of phases. Okay, different phases of a pandemic. Okay, fine. Or an epidemic.
Also, perhaps trying to focus on sort of issues of preparedness and thinking about the future, and not just, I mean, obviously what the challenges are now is really important, and part of that is going to be what the challenges are for the future. But if we can sort of frame it in a fairly general way, not just for COVID, but using that to illustrate some of the issues.
Yeah, I think so. It shouldn't be really just COVID. That should be used as an example, I think.
Yeah.
One important thing is also the data collection and the design of data collection, because this has been a tragedy, I think, in this pandemic. I mean, there are all this data on the testing which cannot be used because they were not thought, or they were not collected, or they're still not being collected, as if they were being used for epidemiological tasks, if you say, or estimation. It's just an operational stream that, you know, they have to test a given number every day, and they just move things around according to what the need is, and you can't really make any sense of the data because the changes are, you don't understand what is producing the changes. So the numbers they report every day to 22,000, you know, it doesn't mean anything. It doesn't mean anything in terms of the pandemic. And I think from a statistician, I suffer every time I hear these numbers every night, because they don't mean anything.
There's two things. There's supposed to be a paper on data estimation, though discussions have not got very far with that yet. So if anyone is interested to join that, that will be helpful. But the other thing is, with apologies, I must go in a minute, but I think on this framework, several people have put in the chat more ideas, not just my simple idea, but some more ideas for how we might structure the thing. So I would suggest as sort of homework for next week that the people who've put out, particularly the people who put ideas in the chat, but anyone should try to write at the very most a page, maybe half a page, and it could be bullet points or whatever, suggesting a little bit more about how we might structure this, whether we can think of a structure into which to drop all the kind of things we've discussed, which both to some extent follows the sort of phases of an epidemic, as I've suggested, but also looks at it from some of these other, how you'll integrate some of these other cross-cutting discussions we want to have into such a structure. So, you know, it could be very vague, just ideas, just bullet points, just phrases or something. You know, it should be 1, 2, 3, and 4, and write for each of those, write a few bullet points or topics that could be discussed there. I think if a few different people did that and put that in the Dropbox and just call it, you know, structure TJ or structure Glenn or structure Danny, whatever, then we could have something to discuss next week. And, you know, and some people might just want to write a couple of sentences to say, I don't agree at all, we should do it some completely different way or something like that. Or, but I think if people would just write some things down on the structure, that would be very helpful.
I think that Danny and TJ and Paul and one or two others had already had some discussions before we started today and had some thoughts about that structure. So it might not be individual things, but rather a collective thing which we can add.
Yeah, if people collaborate and put their heads together, that's so much better. It would be obviously. Yeah.
I know there are people that they are raised hands. Let me just ask a quick thing before I forget. Jasmina, you talked about a draft of this modeling paper. Would you be able to circulate it so we see where you left it? I know it might be just a very drafty draft, but
can I just tell you, can I just please say that yes, but maybe after we have our meeting tomorrow, because we're writing different parts of it, and Valerie had written so I'm going to not say it correctly because there is different groups, but loads of people have written different parts that will come together hopefully tomorrow at 10 a.m. Makes sense, and then we can circulate it. But I think But can I just say that maybe it's better if we do this afresh, because we may get different ideas and we might get biased if we read that paper.
Okay, fine.
Dennis, what do you think?
A quick point, and then Glenn, because Glenn's had his hand up for ages. Dennis, did you have a quick?
It was just to say that the stuff is in the Dropbox. There's the title in under challenge 6. There's something called begins CHP06, which is Glenn's overall draft, and then we are trying to flesh out the various bits of that. So there are ones which are called 6.0, 6.1, 6.2, 6.3. We haven't yet got a draft for 6.4 or 6.5, but things will perhaps be a bit clearer after we've had our discussion tomorrow morning.
Fine.
But I must go. So thanks for a very good discussion, and keep in touch.
Yeah, thanks.
See you later.
And any questions about access to the Dropbox for anyone or anything like that, just email me.
Yeah, of course.
Thanks, Dennis. Glenn, you still got your hand up. So
so I can't remember what I was originally going to say, but I just to Danny there. So in that modelling paper, we did identify the idea of data collection and design of data collection being something that you should be probably trying to do and think about. But I did wonder whether it would be more suited to this paper than the modelling one, because it's really about estimation. And the other thing is, I was just going to put a pitch in for I very much like the idea of the UQ framework and also expert elicitation as a way of kind of trying to handle uncertainty and estimation when you're when you're trying to make decisions or sort of provide information to decision makers. But I would just put a bid in for just the technical problem of doing estimation for epidemic models across the range that we've discussed, because in my view there's an awful lot of stuff I can't do, certainly, and I think that we would like to be able to fit more complex models with confidence and speed, better than we can. And then just finally, I kind of wonder whether, so in the modeling chapter, we're talking a lot about structures of models and processes that we might want to include, but I do think that possibly a place for another type of model, so that that's in my language, that's a process model, but we also need to think about the observation model, and I feel that I need to think much more about how to do the observation models. And at the moment, I think it's all a bit, it's just, I stick my thumb up in the air and sort of hope for the best, so I think there is some scope for thinking much more clearly about that, and probably that other people in this room have done that.
This business about developing the observational model is linked to the data as well, because obviously it gets really complicated when the data are affected by biases, and you have to model that, because otherwise, if you just take them as a given and you interpret, I mean, there are lots of problems at the moment with people that use very complicated and sophisticated models, but the data are meaningless. So unless you build that additional aspect of the observational, which links the model with what you see, which is not what you would like to see, but what you see, then there are problems. I think the observational model is a fundamental. You're right.
This kind of leads us to the problem somewhat, is that all these challenges sort of ask these questions. So, for example, you don't trust the data because you suspect systematics, or you suspect, alterations to the data. The data isn't quite what it is. So again, that prompts uncertainties, because you don't know what the systematics are. You don't quite know their behavior until you've modeled them in more detail. That's an additional uncertainty. Now, if you try calibrating your model before you've understood that, obviously your calibration will run into big problems. So the meaningful estimation of anything requires quantifying uncertainties of all the main things along the trajectory from your model to the real world, right? So my issue with all this, I guess, is that there are many ways one can go wrong here if one has missed just one of those pieces. Okay, so I think I don't want to push this UQ framework too much. We could have a very light UQ framework, which just has a paper which says, by the way, within your analysis, there should be a model, there should be some understanding of the observational process, there should be an understanding of how your model is deficient, because when your model is deficient, it's deficient in a very different way from how the data is deficient because of the observational process. The error structures on these two things could not be more different. Okay, so we could just have a very light touch structure which just says model, reasons for model being wrong, data, reasons for data being wrong, processes there, which the user can fill in whatever sort of game they're in, and then we could quickly move on to some hardcore techniques for actual estimation models in the temporal setup that Dennis was talking about. So I don't want to push the UQ framework as being the core of the paper, but without it at all, you're in this horrible sea of estimating things that just aren't really true, because your data isn't what I think it is, your model isn't what you think it is, and then you're chasing parameter space around in circles because you're just not fitting the right thing.
May I just put in a short comment on this? I mean, we are all more or less experts on either confidence intervals or credibility intervals or uncertainty quantification, but is the world ready for that? I mean, do decision makers know what to do with uncertainty?
That's an excellent question. That's an excellent question. Sometimes absolutely not. Absolutely not. On the other hand, to ignore it, it would be a mistake too, I think.
But I think, to my mind, that is where we kind of close the paper, maybe, with the expert elicitation people, because all this information could be fed into some sort of expert elicitation, which would then, hopefully, I assume, be presented in a way that would be understandable to policy. So maybe. I don't know. He's laughing.
The ability to give a clear probabilistic forecast that you trust, that has uncertainties in it, that you can track back to all these different places, models, observational process, data issues, et cetera, to be able to give a probabilistic forecast which at least incorporates that uncertainty is a good start. To then persuade a decision maker that they should, use the formal routines of decision theory or something similar is a very challenging problem. But if you don't even provide that, then you are definitely going to mislead them in some way or another. So if you don't provide uncertainty that's sort of rigorous and associated to clearly defined things in your calculation, then that's going to be a problem sooner or later. But I agree with you. Is the world ready for uncertainty? Sadly not. It's not. But on the other hand, I think it is our responsibility to try and change that, to push on that door. And it may be very hard.
The reason I asked is that a long time ago, I for medical people, produced a kind of method that gave, in that case, confidence intervals without any estimate in the middle. And they said, this is useless, we need a number. And that probably reflects what you say, that not everybody is ready for uncertainty, but it has to do with estimation. That estimation is a way of, in a certain sense, giving a number. So it's a way of fooling people, even fooling ourselves in the models, that we use a certain number. We don't run our numbers with variation of the parameters according to distributions in every parameter, because that would be very heavy to do, right?
We should though, but I agree we don't. But we should get as close as that as we possibly can. But you're absolutely right, we don't, because it's computationally a nightmare. But there are methods which allow us to get closer and closer to that. But I agree, it's a real problem.
Is that something to talk about in estimation?
I think it's a part of this paper. I don't know whether at the end, whether at the beginning, I don't know, but it's an important point. There are lots of people who want to say lots of things.
There are, I think the participant list puts them in order. So I think Glenn must have had his hand up longest, unless it's the hand that he didn't put down earlier.
Yeah, sorry, I've not put it down, sorry.
Right, well, in that case, it's Samitra. Samitra?
Yeah, I mean, I'll just add on to what Ian was telling. I mean, this inadequacy, I think that has a profound effect on the middle, not just the confidence interval, in practical sense. I mean, so if we don't capture the epistemic uncertainty, that has a significant effect on anything we do. And so I don't think that uncertainty quantification is an optional thing. I think it is central, because if we do not capture both the aleatoric as well as the epistemic uncertainty, then it's not just the confidence bound. Where we stand in the middle gets swept away. And that happens significantly. And in my practical experience, even little effort to get the epistemic uncertainty actually have a lot of practical benefits.
Okay, thank you.
Agreed.
And Joshua also was going to say something.
Yeah, it's just on the idea of presenting ranges without a point estimate, because that's what Sage are doing with or SPI-M are doing with the R numbers, and have done throughout. And I actually think that's kind of helped in some ways, because it means that when the media quotes it, they can't quote a point estimate, unlike some stuff we put out where we put out, I don't know, R to 2 decimal places with an uncertainty interval, and then you get this beautiful map on the BBC with the whole country, with each area with its R number to 2 decimal places, and then you're like, oh, this one's 0.02 lower than this other one. That's the worst place in the country, which we know is nonsense, but isn't presented that way. So I think playing around with different tricks like that, or different visualizations as well, can actually be very useful, and is a big part of how to get these results to be useful to people who aren't statisticians, which is ultimately what we want.
Yeah. Every time they report these vaccine efficiencies or efficacies or whatever they are, I wonder, they're always given to a decimal place and so on, and I don't know how accurately they're actually able to estimate those. but I would quite like to see some error bounds on those. Anyway, that was just just me. I think nobody's got their hand up anymore. Have we ground to a halt? I think we probably have.
Yes,
People need to get away. So just to say, Ian, we had a discussion about when to have these meetings, because you remember we discussed with Peter, and everybody seems to be happy to move to Wednesday. So
sure.
the plan will be same time, but on a Wednesday.
5 o'clock on a Wednesday.
5
Cool.
o'clock on a Wednesday. So hopefully Peter would be able to come along as well. And that should be in the bulletin with the link tomorrow, but it'll be the same link as we're using today, but for Wednesday. Other than that, I think, so thank you all. Lots of bullet points are going to be produced, hopefully, and then we can all try and sort of. I think we just have to get started once. I mean, that's what happened with the modelling thing. Once one starts to get a list, and then Glenn was wonderful about getting it into shape for us. But then it gives people something to build on, which sort of speeds things up a bit. So anyway, thank you very, very much. So see you again soon.
Yes, is it possible for you to send us an invite so it gets in the calendar?
I don't know about that, but I'll check it out.
Thank you.
You want a calendar, little, yeah, I know it is very helpful.
I mean, I can.
I'm sure we can. I'm sure I can do that.
I've just remembered now, so I can do it and put in there, if you see what I mean.
I'll ask Kira, because I'm not sure if I set up the Zoom to invite you, I'm not sure I can use the existing link to get, to get the get us in the right place. But we'll try and check it out before next week. Okay.
Thank you.
All right. Thanks. Thank you very much.
Bye,
everyone.
Bye.
Thanks.
Bye,
Bye.
everybody.
Bye-bye.
Ciao, Jumpy.
Oh, I should just say, for those 4 of you who are still there, I did record this, but I didn't start at the beginning because I forgot, because I'm useless as usual. But we've got, again, most of it captured. So if at any point we need to go back, but I think people will remember what they've said. I don't think we'll need it, but there is a recording up there somewhere that
I have downloaded the chat, for instance.
Okay.
Yeah. The previous recording in Slack. So.
Oh.
The previous recordings were in the Slack channel. So.
Were they? Oh, okay.
Yeah, except the last week ones. I think they were from October's. So last week ones, I don't know if someone has uploaded, but it's better to upload in Slack so that we can all get them.
Okay, well, we'll do what we can on that.
Bye.
Okay.
Bye.
Bye.
Thanks very much.
Bye, everyone.
Bye-bye. Bye.
Bye.